Welcome back, everyone. We are continuing with chapter 3. This is section 3.2. There are two rules. We're going to actually learn quite a few rules in Calculus 1 for taking a derivative. The first one is the product rule. It's saying, what if we want to do the derivative of two functions that are multiplied to each other? Well, what we're going to end up with is the derivative of the first times the second function plus the first function times the derivative of the second function. Now, the quotient rule says, what if we want to take the derivative of two functions that are being divided? Well, this one's a little different. You're going to get the derivative of the numerator times the denominator minus the numerator function times the derivative of the denominator all over the denominator function squared. So make sure that you don't just do the derivative of the first times the derivative of the second, be done with it. It's more complicated than that. And certainly your teacher's going to be able to see that. All right, example 1, part 1. If y equals x times e to the x, find y prime. All right, so our first function is the x, that's our f. The second function is the e to the x, that's our g. So we're just going to follow our formula here. So y prime, this is part 1. Y prime, derivative of the first is 1 times the second function, plus the first function times the derivative of the second. Now, the thing is, the derivative of e to the x is just e to the x. And a way to write this answer is going to be to factor out that e to the x. And notice we have product rule again. So there's our first derivative. That's our part A answer, or part 1 answer. Part 2, I'm going to have to take a couple of derivatives before I can see the pattern. So here's y prime. So y double prime, this is for part 2, is a derivative of this. So derivative of the first function, that's e to the x, is just e to the x, times the first function, second function, plus e to the x times the derivative of this. Now, derivative of the 1, it's a constant, that's 0. Derivative of x is just 1. And let's clean that up a little. I'm going to factor out an e to the x in the front, and I'm left with 1 plus x plus 1, e to the x times 2 plus x. Let's try the third derivative, which means I'm going to take the derivative of this now. And we're trying to look for a pattern, of course. Derivative of the first function, e to the x, just e to the x, times the second function. Oops, that should, yes, equals. Plus the first function, e to the x, times the derivative of the second. Now, that 2 again is going to go away. It's a constant, and I'm left with just the 1. Factoring the e to the x out again. And hopefully we're starting to see a pattern. First derivative, 1 plus x. Second derivative, 2 plus x. Third derivative, 3 plus x. Let's do a fourth derivative just to make sure that the pattern holds. After the 3 ticks, we usually go to the parenthesis notation. So this is the fourth derivative. I'm taking the derivative of this, of course. Derivative of e to the x is e to the x. Plus e to the x times the derivative of this. Once again, that 3 goes away. I'm just left with a 1. Factoring e to the x out. And it looks like the pattern is holding. So let's generalize this into the nth derivative. All right. That's going to be e to the x times. Now notice it's the same. Fourth derivative 4, third derivative 3, second derivative 2. That is going to be n plus x. There is the nth derivative. A little clever. Let's try another one. We're going to do, we're looking for y prime. So y prime is going to be the derivative of the first part, and that's going to be 2v. Now notice this is the derivative with respect to v now, not x, times the second function. Now to be clear, root v is v to the 1/2 plus v squared times the derivative of this. Now I'm going to go to the side here and show you the derivative of. So if I have 2v to the 1/2, its derivative is going to be 2 times 1/2 v to the 1/2 minus 1, which cleans up to be v to the negative 1/2, which is 1 over root v. So this, the 1 goes away for the derivative. This becomes 1 over root v. Oops, I forgot to switch the color back. 1 over root v. Now we're going to clean that up a little. And I'm going to notice that between here and here, I can factor a v out. And I'm left with 4 root v plus 2. Plus, now, when I factor a v from there, I'm left with v over root v. And let me show you real quick the algebra on that. V over root v. Remember, you subtract the exponents. That's v to the 1 minus the 1/2 power. So that's v to the 1/2. Which turns, remember, one of those v's has been factored out. And we are left here with a root v. And I'm going to notice that I can combine up some like terms here. V times 4 root v plus root v is going to be 5 root v plus 2. Just a quick thing on notation. Notice what I'll do sometimes is I'll put a little tick down like that, just to make it clear that plus 2 is not underneath the radical. So if your handwriting is not kind of like mine, not as great as some other people's, you may want to have a little trick like that, just to make it clear that square root does not include the plus 2. All right, let's try the quotient rule. So we're here. All right. So we're going to find y prime. That's going to be the derivative of the numerator times the denominator minus the derivative of the denominator, which is 3x squared, times the numerator, all over the denominator squared. All right, let's clean this up. Up here, I'm going to FOIL. Here, I'm going to distribute. All over. Whew. All right, let's keep track of this a little bit. So I have some x to the fourths. That's going to be negative x to the fourth. I have x to the thirds here. Let's try to color code this a little. X to the third. So that's going to be minus 2x to the third. I have an x squared here. That doesn't combine with anything. I have a 12x here. That also doesn't combine with anything. And then I have a plus 6. There you have it. Unfortunately, nothing drops out of that. Now you can see using the quotient rule can get quite messy, and it's often avoided when possible by turning things into product rule. But I'm not going to show you the trick in this video. All right, next page. All right. We're going to find the equation of the tangent line to the function y equals e to the x over 1 plus x squared at this point. And to be clear, this is at x equals 1. So we're going to have to use the quotient rule here, obviously. So the slope, which is y prime, is going to be the derivative of the numerator, which is just e to the x, times the denominator, minus the derivative of the denominator, which is 2x, times the numerator, which is e to the x, all over this here. Now, we can factor out in the numerator an e to the x, and we're left with 1 plus x squared minus 2x. All right, now, if I rearrange this, it's going to look like this. And that actually factors to this. So this becomes e to the x times x minus 1 squared over 1 plus x squared squared. All right, so we're going to plug a 1 into here so we can get our slope. Now, very nice for this particular one. At x equals 1, when I dump that into there, notice I get 1 minus 1, which means the slope is 0. Done. That was easy. So let's go to point slope form. You can see this whole part here goes to 0. 0. Which means this is a horizontal line, specifically at y equals 1/2 e. And that is my horizontal line in this case. All right, one more. We're going to find the equation of the tangent line to this function, y equals x squared plus 1 over x squared minus 4. And once again, I want to point out that this is when x equals 3. So here we go. M, the slope, which is y prime, derivative of the numerator, 2x times the denominator, minus derivative of the numerator, denominator, 2x, times the numerator, x squared plus 1. And that's all over x squared minus 4 squared. All right, so we're going to do some distribution here and distribution here. And very nicely, 2x cubes go away. And I can combine up the negative 8x with the negative 2x. So now let's find the slope at x equals 3. So negative 10 times 3. And that's going to be 3 squared, which is 9, minus 4 squared. And I can see this is going to be negative 30 over, that's going to be 5 squared, which is 25. So the slope in this case is a negative 6/5. So now that we have the slope, let's build the equation of the line. Y minus 2 equals negative 6/5 times x minus 3. I'm going to go ahead and distribute that negative 6/5. Some teachers let you leave it like this, which is fine. I'm going to take it all the way to slope-intercept form. So I'm going to distribute the negative 6/5, and I'm going to add the 2. Getting a common denominator here, this is going to give me y equals negative 6/5x. That's going to be 10/5, 10 plus 28, or 10 plus 18 is 28. And there is our equation. I hope that was helpful.